Okay, so let's talk about curve shape. And the activity that I had us do last time was, if I give you a function, like here's g of x, can you sketch what the derivative should look like? And the trick you're supposed to do is just estimate the slope moving along the points. And so we get something like this. And so let's just make sense of it real quick. Points of interest would be when the original function in red, g, has a horizontal tangent line. So that's typically peaks and valleys. Later we're going to use the terms mins and maxes. Not always. But, all right, so when it has a horizontal tangent line, that's when the derivative, this dashed line, crosses 0 or touches 0. It's when the derivative is 0. And notice on the red line, as I come down, that's a negative slope. So the dashed line is in the negative y values. How far down it is, how far down the dashed line goes, corresponds to how steep the slope is. So when I'm getting close to 0 in this little region here, my slope is not very steep. That's the region where the dashed line is close to the x-axis. All right, and so in fact it's not too much easier to read, but now let's highlight when the derivative is positive. Okay, and let me take away the derivative function for a moment. Well, right, derivative being positive means the dashed line is above the x-axis. So right here, the dashed line's above, and over here, the dashed line's above. But I'm going to take away the dashed line, just so that way it's less busy. And I want you to notice the derivative being positive corresponds to when my original function is increasing. It's when you're walking uphill if you lived on this graph. I'm increasing, here I'm increasing, right? So that's when the derivative is positive. Similarly, the derivative being negative corresponds to when the function is decreasing. And you always have to move from left to right. So imagine you place a ball here, the ball rolls downhill. My function is decreasing, which means my derivative is negative. And again, if I put back up the derivative is below the x-axis. That means my red function, my original function, is decreasing. All right, we can take the derivative of the derivative. And all you have to do is just pretend you started with this function. And now graph the slope of this function. Okay, we weirdly didn't. We really started with the red function, so the dashed blue line is the derivative. But now I can take the slope of the derivative, and that's called the second derivative. Here's what that looks like. Now this is getting really busy, so I'm going to remove the original graph for a moment, just to make it less busy. And what's going on? Well, the second derivative touches 0 right here, and that's when the first derivative has its peaks or valleys and things like that. It's just like before. And as I move from left to right, I'm going uphill, 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 uphill. That means my derivative is positive. This is the derivative of the derivative, so it means my second derivative is positive because my first derivative is increasing. So I'm going to write all this down, but I just wanted to show you these pictures before I get to writing it down. I could similarly have, show me when my second derivative is positive, and it corresponds to when my first derivative is increasing, because it's just the derivative of the derivative. So derivatives have the same relation when you take them. But, okay, here's where things get interesting. Let's take away the graph of the derivative. Let's put back up the graph of the original. Okay. Now, what's the relationship between the original graph in red and the second derivative, which is the dashed green line? And I'll just tell it to you. It's something called concavity. So when the green dashed line is positive, meaning above the x-axis, that's when the red line has a U shape to it, right? It's a bowl, and it's facing up. That's called concave up. It has nothing to do with increasing or decreasing. Notice over here, the red line, that is decreasing, and now it's increasing. And all along, the second derivative was just positive. It has to do with the curvature, right? It's curved, it's a happy face. In white, it's a frowny face. By it, I mean the red line. The red line is now a frowny face. That's concave down. And that's when the green dashed line is negative. Okay, so